Good morning. What? Go quick. If you have to ask yourself if it's bad, think hard and long about before you ask it. I don't know. What? How about you ask me personally? Okay. So as we're looking at stuff, last class we did long division. Now today we are just continuing on from there. So in your notes, the last thing we had was probably a couple examples of long division, right? Okay. Today, same section, but we're going to finish up the section today. We get this new idea of synthetic, which real quick, what does synthetic mean? Fake. Good, I'm fine with that. Synthetic division. Now, when we think about synthetic, fake is a fine way to do it. Artificial, man-made, something like that, right? Like I can buy a coat that's synthetic wool or synthetic down that they just didn't pluck all the feathers out of a goose, but it's the same texture, same sort of stuff. Synthetic division is so unbelievably powerful and convenient for us. We're going to make use of it. Okay, so right off the bat, just as a division, or sorry, as a definition rather, instead of just saying fake division, we're just going to make the following comment. This is simply looked at as a shortcut for division. Shortcut when dividing, and we have to be really careful here. We divide by a, and I'm going to pause to make sure everybody catches up. I'm going to change color, make it big and bold so that it's really clear. We can use synthetic division, which is simply a shortcut when dividing by a, and then here's the color change. I'm going to do it in this blue color. Linear factor. And you don't have to bold yours, but I just want it to stand out. We can use synthetic when dividing by a linear factor of the form x minus k. Now, really, really, really important here. We can only use synthetic when we're dividing by something linear, and it has to have this form. Now, the biggest thing that I want us to take away, two things, but one of them is much more important. What is the power of x? That's what means linear, right? So this is a linear factor. Does what we divided by on our bell ringer match that? Are you sure? What is the coefficient on this x? What's the coefficient on that x? Do they match? No. So we're going to really highlight that. When we look at this, I'm going to use the same blue color, and I'll make this comment again. We never write these numbers unless we're trying to drive something like very clear. It has to be 1x. Now, we can make that comment here. The leading coefficient must be 1. Okay, it has to be 1. If it's anything but 1, you cannot do it synthetically. Okay, we have to have x minus k, and there's a few things that we're going to pick out. Now, we're going to see, just as an example, I think that a lot of people in here prefer to have steps, like do this, do this, do this. There's a lot of repetition in the way that this works. Just like when we do regular division and we'd say multiply the queen by this, subtract. Multiply the queen, subtract. We do that over and over, right? We iterate is what that can be called, just time after time. So as we're looking at this, here's what I think that we should do. We're going to go ahead and, rather than just defining it because it's kind of ugly, we're going to do an example. And as we're doing the example, we're going to work out steps. So here we go. We'll say for this problem, synthetic division, we have steps and we have an example. And we'll just do 2 quick columns. Okay. As long as we are dividing by a factor of the form x minus k, we are fine. So let's check it out. This first one, we're going to say steps, step 1, we'll just say rewrite, and we'll get there here in just a second. Rewrite and identify, which I'm just going to use ID, missing powers. All the same. Missing powers. So if we have a missing power anywhere, what are we going to replace it with? 0 of them, right? We just physically write the 0 for our coefficient in front of it. Okay, so let's see the problem that we're working with. On this first one, we were asked to solve, and this is kind of that example with the rewrite, and we'll do the same stuff. I want us to do, we're dividing by x minus 3. That's our divisor. And we have the following. I want to know, does x minus 3 go into 2x cubed minus 7x squared? And I'm going to leave an awkward gap, minus 4. Now, I'm trying to save us just a little bit of time in the writing. The real problem was just this. 2x cubed minus 7x squared minus 4 divided by x minus 3. What's the point of my awkward gap? Yeah, we're missing a power, right? Like, we should identify those and make it a habit to replace. Does it matter if I do add or subtract? No, it's 0. Doesn't change anything. I'm going to put my missing power right here, plus 0x. Okay. Now, we haven't really rewritten it. All we've identified is the missing powers. So here's what we're going to do. And this first one, it's going to be ugly. I don't have a nice way to do this. Step 2, we're just going to say rewrite synthetically. So make or rewrite synthetic box. And we'll see what this means, because we've never seen this before. I don't think. You guys didn't do this in Algebra 1, right? Okay. This is like the handiest thing ever. I promise. If you love division, nobody probably loves division, but that's okay. So much faster. Okay. Here's what we're going to do. We're going to make our synthetic box, and we're going to make 2 comments. Outside of our synthetic box is k. Now, this, if we look up in our notes, we're dividing by x minus k. What is k in this situation? So x minus k, what is written right here? X minus 3. So what's k? Just 3. Because it's already in that x minus form, we're just going to use the 3. Okay, so I'll put that in parentheses here. Outside the synthetic box, we're going to put a 3 in this case, because it's x minus 3. And then inside, and we'll go back to green, inside of our synthetic box, and we'll see what that means in a second, are coefficients of divisor. Or sorry, dividend. Coefficients of dividend. Okay. So we're about to do our synthetic box. Now, when we do this synthetic division, some places are going to look a little bit different. Your book uses a very, very, very slight difference in the notation that I do, but that's okay. You will, like, I'll show you guys how they write it, how I write it. It's just a little tiny bit different. So here's our step 2. To make our synthetic box, it's so easy. Everybody knows this division symbol. We're just going to flip it. So here it is. Boom. This is what I'm going to refer to over and over as a synthetic box. I've just flipped the division upside down. And it's weird, I know, but we're going to get through it. Okay. Outside of this box goes k. What is k again in this problem? So I'm going to put a 3 right here. Now, inside the box go the coefficients of the dividend. Now, it's hard to tell, but I have 2 levels here, and that's very intentional. Can you help me identify the coefficients of whatever we were dividing in the first place? 2, and it's x cubed, right? Okay, and then what's the next one? -7. The next one? A 0. And the next one? -4. All I've done is in this top row in my synthetic box, I just put these coefficients. I want to caution, I know I've done it before, but we're going to do it again. If you don't have the 0, you will not get the problem right. Like, there's no chance that you'll get it. You have to have the placeholders. Okay, so once we're here, this is super easy. And the problem is kind of ugly, but we're going to make sense of it. I'm going to, now that we have all this written, that was all step 2. Step 3, and I'm going to switch colors, and I don't know, do you want me to have like step 3 and just have this written again and do the same thing? Or can I just keep working on this and say, here's step 3? Okay. So I'm going to switch colors just in case it helps. 3 will be in yellow. So for step 3, we are going to, whenever we run out of space in long division, how do I get the extra term? We think of a famous rapper. We drop it, right? And who's the rapper, just to be real clear? Ooh, it was actually Snoop Lion. So I don't know if you guys know, but he had a little side thing in the mid-2000s where, whatever. Okay, we're going to take this 2, and we're going to drop it straight down. So drop LC straight down. Okay, there's a couple steps in here, just so you know. So I drop it straight down. I write a 2. Now, with division, remember, this is very similar to writing the first number of our long division, if we were to do it. I then take this and I multiply it by whatever we divided by. That's how division normally works. I'm going to do the same thing. I'm going to multiply the k value and that first leading coefficient. So a couple steps here. Multiply. I'm going to make that a star so it doesn't look like a minus. Multiply k times the leading coefficient that was just dropped, which in this case is going to be what times what? 3 times 2. Write product, which is just the answer to a multiplication, below next coefficient. Coefficient. Okay, so I'm going to let everybody catch up with the writing just to make sure that if I'm doing something, you don't miss it. I dropped the leading coefficient straight down. I'm now going to multiply whatever's out here and this, and I'm going to write it directly underneath which number? The -7. This is the next coefficient. So help me out. What's 3 times 2? 6. I'm going to write it here. And we have one more step. So I'm going to say we've done this. We dropped the leading coefficient straight down. We've multiplied it. And then write the product below the next coefficient. Add and repeat. Add and repeat. Now, this one, again, I'm trying to make sure I'm looking to see how people are writing because this is weird. The first time we do it, the first couple times it'll be strange, but I promise it's so nice. Okay, when I say add, is it fair to say that we just add these two? What's -7 plus 6? And what do I mean by repeat? We're just going to do this one. What's 3 times -1? -3. Okay, I'm cool with that. How do we repeat then? 0 plus -3? -3. And one more. 3 times -3 is -9, and that gives me a -13. Okay, we have just simply multiplied over and over and added straight down. If you need to make a comment, and we'll see a few more of these just to get practice, but is this easier seemingly than long division? Now, here's the cool thing. I'm going to add one more little piece to my synthetic box, and we didn't mention this yet. I'm just going to say it was in here the whole time. We just didn't draw it. Why do you think I might have had that little hanging piece? Any guess? I'll even make a big claim. I'll tell you, x minus 3 was not a factor of this. This piece here. This is my remainder. Okay, now, as we write our answer, it can be tough to pick out at first. We're going to look back at the original, and this will be step 4, but I'm going to write it here just so it shows up a little bit nicer. Step 4, the very end of this. And I'll switch colors one more time. We'll make this one orange. Okay. The new numbers, these numbers, and I'm going to say 2, -1, and -3 are coefficients of a polynomial, and I'm going to say of the quotient, specifically, I suppose, with power. And we're going to pause here for one brief moment. We now have the coefficients for a new polynomial. And it happens to be the answer to our division that we call the quotient. And I've misspelt it. I forgot an I, which is not super common. Quotient, my bad. Okay. We started with what degree in our dividend? X to the, what were we dividing? What was being divided, our dividend? So it was a cube, right? And we divided it by a linear. If you took x cubed and divided it by x, what's the new power? And I'm just going to write it here. You guys don't need to write this. I just want to think about it. There's more to it, right? ... But if you did x cubed divided by x, what's your new power of x? X squared. So we're going to say these are the coefficients of the quotient with power 1 less than dividend. And beyond that, remainder in the last entry. And we can say last column or row. Column makes sense. Do you guys agree? This is my remainder. Last column. Remainder, just to make sure really clear. Okay, so now all we have to do is write our answer. And this thing, I promise you will learn to love because it's super handy. I started with x cubed. And we just decided that it's going to start, the answer is going to be with x to what power? 1 less. It was cubed. What's 1 less than x squared? So check it out. We're going to write our answer here. And here it is. I'm going to write it kind of fancy. We're going to call it q of x. Any guess why I would call it q? Quotient. Awesome. What are the coefficients that we just got out of this? The very first one was a what? 2. And one more time, what was the power that we're going to kick out at? X squared. What's my next coefficient? So not 7. I'm looking here. We got the 2 minus 1x. And you can write the minus 1 if you want. It's the same thing. One more. Minus 3. And then here's a weird part. How do we write a remainder? Negative 13 over x. What was our divisor again? X minus 3. And we're done. Now, looking at this, was this seemingly a factor? If it were a factor, and I'm going to keep stressing this like crazy, if it were a factor, what would the remainder have been? 0. I want you guys to look back in your notes real quick. See any of the examples that we did last Tuesday. Are there any that have a remainder of 0? And a linear divisor. Give me one of them. Do we do x minus 1? Okay, well, let's try one more. I want you guys to do one. Before we say just do it on your own, questions here. Any part of this where I've lost you along the way? Kennedy? These ones? Here? So this one just drops straight down, the 2 does. And then once I get here, I'm at step 3. So I drop that, and then I multiply this number times whatever I write here. So what's 3 times 2? We write it in the next row, and then we add straight down. What's negative 7 plus 6? So now we do the same thing. We multiply, and we just get it. And it just it repeats itself over and over until we get to the end. Okay, so let's try one more. I wish we could use our bell ringer. Any other questions? RJ? Absolutely. So if this had been a 5, I would have dropped a 5. Or if it had been a negative 4, I would have written a negative 4 straight underneath it. Absolutely. This is a leading coefficient of my dividend. 100%. Nice language there. All right. So this time, we're going to do example B. And I think we did this example last week. You can probably check. We're going to write it the nice way. I'm going to have the following. On B, I want 3x cubed minus 5x plus 10. And we're going to divide this thing by x minus 1. Okay. We'll do one more together, and then I'm going to let you guys do one on your own. This stuff goes super nice. First off, is this eligible for synthetic division? How do I know that? It's of the form x minus k, right? Now, it's 1x minus 1. I'm cool with that. What is k in this problem? Just 1. Now, it's weird, right? Because it has to go opposite, because in our definition, we say x minus k. So if that had been a plus 2, we would have had to do x minus negative 2, and it's that wonky backward thing. But all right, on the outside then, and I'll just make a comment, k equals 1. And let's just go ahead and start our synthetic division stuff. And we'll be mindful of one other thing here in just a moment. What goes outside of my synthetic box then? A 1 goes right up front. Okay, here's my synthetic box. And we have to be so careful here. But I imagine with me cautioning you against it or about it, we'll probably be okay. What goes in this first top row here? A 3? Got him. 0. Why 0? There's no x squared. We're going to use a placeholder. And in fact, we have to use a placeholder. On long division, you might be able to sneak by sometimes if you don't have the placeholder. Like, it'll maybe still work. But this one will not. We have to have that 0. Okay, after the 0, Michael, I'm going to continue with yours. You said -5? And then the last one? 10. Now, you're right, King, it is +10. And I like to draw this box right here, just right from the start. All right, so here we're cooking. Looking at this. Kyle, how do I start? What's the very first thing that I do, like Snoop might? What am I dropping? Not the 1. What's the, if we look up, did you have all this written down? I dropped the very first thing here. It's 3, and the whispers are helpful, but remember, it's not like I'm not really concerned if everybody else knows it. I'm checking individually there. Bless you. Okay, so like it's hot. 3. Now what? 1 times 3 is 3. And what do I do with these? Ooh, careful. Add. What's 0 plus 3? 3. Now I do 3 times 1. Like we just repeat this process over and over. Gives me another 3, which I think is -2, right? And last one, -2, 8. Okay, so right off the bat, on this, we have, and I'm going to clean up some language here, and we'll write our answer nicely, but I just want to highlight here, these things are parts of Q of X, which remind me again why I'm choosing Q. These are my quotients. Okay, and then just some other nice language, because most of the time, or at least some of the times, these guys come out to be like uglier. I'm pretty tempted, and I'm going to call this R of X. Why R? It's my remainder. Now, once we've done all this, we are good to write our answer. And the only thing that we ever have to look at is, can you tell me the degree of the dividend? So the dividend had a degree of 3. Whoever answered 2, you're giving me the quotient, but I like that answer. So here we go. Boom, we have our answer. Our quotient is 3, and it's x to what power again? Squared, plus, what's my next term? 3x minus 2, there's my quotient, plus over the remainder. Okay, or sorry, the remainder over the divisor. Is this nicer and faster than long division? Oh my gosh, so much. Kennedy. So these right here are the coefficients to here, and I'll like see if I can't match these. This 3 is this 3. And this one. So because we started at x cubed, and I'm dividing by something with just an x, I know that, like, if I think about the long division, the very first thing I would have to multiply x by my queen, right, would be an x squared. And that's just showing up down here. It's always 1 less. Okay, doable? Whoa, lots of questions. Hit it, Ronaldo, and then we'll get you, RJ. Yes. Yep, this process is 1 times 3 gives me 3, and then 1 times 3 gives me 3. Like -5. Yep, so each time we do this, RJ, it's the first one is this times this to get this. And then the second one is whatever this adds up to times this to get this number. And it just repeats over and over. So the next one would be this times this, and it gives me this number, and just over and over and over. Okay. All right. One more together. Okay. So let's check here. Oh, man, there's some awesome things that go on here. I want you guys to do one more for me. And let's see here. Oh, we get a couple theorems out of the deal. We should do one more. Okay, so let me see somebody's notes. Can I see your notes for just a second, Mark? Is that okay? Okay, I'm not going to put them up on the screen. I just want to look from last week. Do we get any with remainder as 0 last week? Here it is. That's a big one. All right, so we'll get a nice one. So one more, checking this out. I want you to do the following. And even if you know the answer just before we do it, I still want you to do the problem with the practice and synthetic division. I want to take x plus 1 and I'm going to write it as long division, but I don't want you to do long division. X plus 1. I want to see if it goes into, and I'm going to leave some awkward gaps in here. Let's say it's x cubed plus 1. Now, right off the bat, before we do anything, I've left a ton of gaps there, right? Like, there's a reason for it. Do we have a way to factor the sum of cubes, like 2 cubes? Did we have an identity that said if I wanted to factor x cubed plus 1, I could? Yeah, I just take the cube root of each and it'd be x plus 1. I think we're going to be able to verify this with our identity. Why did I leave the big awkward gap here? Zeros. So which ones am I missing? 0x squared plus 0x. Now, the long division is not terrible, but I don't want you to do the long division. Before I say just do this on your own, I need your help with one little piece. What is k? -1 this time, because x minus -1 is what's going to make this happen. Cool. I want you guys to do it synthetically. I'm going to give you like a 15-second head start, but realistically, if you're feeling comfortable with it, you'll probably be done at that time. I'll give you just a moment. If this is my synthetic division, what's my remainder? And what's the significance of that? What's a factor? X plus 1 is a factor, right? Now, beyond that, if I wanted to actually write my quotient, what is it? X squared minus x plus 1. Now, if we check back, and there's some additional stuff that I'm just trying to, you don't have to write it here in this lovely pink color, but I do want to make a couple notes. If this was f of x, like this whole thing, or p of x is what we usually use because it's a polynomial, this was a factor. We now know that if this is p of x, and we're about to summarize this, and this is just nice little entry into it, my polynomial that I originally started with, this big ugly thing, we've just found that it can be written as x plus 1 as one factor. And what was the other factor? X plus 1 went into it, and what was my quotient? X squared. And why x minus 1, Michael, just out of curiosity? Okay. So looking at this, are you okay with how I got this? Here's my divisor, and my quotient. Okay, if they both work, then they both must be factors. If you go back and check your difference or your sum of cubes, you will see exactly this formula. Cube root of the first is x, right? X cubed comes to x. Cube root of 1 is 1. And then we take the first term squared minus, multiply them, and plus the second term squared. We have our entire factorization. Yo, p of x is just this thing. We call it p for polynomial. Yep, I have determined that this is a factor, and it matches exactly what the identity would say, which is a good sign. Okay, in these two things, there is some really valuable stuff that we have. If I wanted to know p of -1 for this example, what would we get? Like, here's my function p of x. What's p of -1? What's -1 cubed? -1 times -1 times -1. So, but if I did p of -1, do you agree it's just -1 plus 1 is what? P of -1 is -1 plus 1. What would that give me? And we're going to make a little note here. I lied. I want you to write this one. I'm going to switch to orange instead. I want you to notice something, and we're going to look at the couple of the previous as well. If this is p right here, p of x, and I did p of -1, it gives me -1 cubed plus 1. Again, here is my function p. It's just some polynomial. And what does this give me? Negative 1 cubed, negative 1, plus 1. Is that 0? Okay, and you're probably going like, all right, I was good a minute ago, but now what the hell's going on? And that's okay, because we're going to see an awesome connection here. Maybe there's nothing too crazy here, but I'm going to scroll up a second, and I want to notice something. If this is p of x, just like we did on the previous problem, and I tried to do p of 1, let's just see what would happen. What's 3 times 1? It'd be 3 minus what's 5 times 1? Plus 10. Let's see, that's 3 minus 5 is negative 2, plus 10 is 8. Huh. Well, that's weird. That's the same, isn't it? Whoa, it was the same here too. What do you think is going to happen if I look at this first one and said, hey, what is p of 3? I bet it's negative 13, which means we just found an easier and faster way to evaluate some functions. We have 2 quick theorems, which we don't get many in here, but we get 2 quick theorems that we're going to summarize and make these connections, and then we're done. So check it out. 2 theorems, and this is how we're ending this section. So we'll call this our own last little thing, and I don't like that color, so we'll use this one. We get 2 theorems. And everybody's favorite thing about geometry is anytime you had a theorem, what did you get to do with it? We got to prove it. Sorry, we don't get to prove these ones. All right, so check it out. First one, we get what is known as the remainder theorem. And this is the one that I was just kind of highlighting, the remainder theorem. And it turns out that we've been referencing at least one of these, not this one. If I take p of x is some polynomial and divide it by x minus a. So any polynomial that you give me, as long as it has nice powers and stuff, and we divide it by this, x minus a, which works really nicely for our synthetic. Maybe it doesn't matter what we're dividing it by every time, but we'll say this. If we do this, then p of a, if I wanted to evaluate it, is equal to the remainder every single time, which maybe, depending on calculator stuff, this is super valuable. I'm going to scroll up so we can still see it, but I just want to highlight what just happened. If I had this function and I wanted p of 5, and this one's not terrible because it's x cubed plus 1, but I could do synthetic division with a 5 right here, and I would get 126 right here, guaranteed, because that's what p of 5 would be. It is an easy way to calculate it without having to worry about taking the cubes and stuff. We'll get more practice with that. Every time, here it is, and we'll use both of these here in just a moment. One more theorem, last one. And we'll see an example with this. It doesn't have to be 1, it depends on what we're dividing by. Okay, last little one is what we call the factor theorem. And this one, we've not explicitly said we've not called it the factor theorem, but we have been talking about it over and over. How do I know if x minus a is a factor? Through division. We'll say x minus a is a factor of p of x. And that's just some bigger thing. This is typically my dividend. What do we need to be true to know it's a factor? If and only if the remainder is 0. Every single time. Now, every single time we can use these. So just a quick check here. If we're trying to use the remainder theorem, and we've used the factor theorem over and over and over. It's every time that I've asked, is it a factor? We're just emphasizing that idea. The remainder theorem feels a little bit less natural, but let's check it. So we'll do one quick example, and this is the last one that we're going to do in class today. So check it out. I'll call this f. I lied. I'll call it p of x just so it looks about the same. Let's say it's 2x cubed minus x squared plus x plus 3. Okay. This thing, we're going to use the remainder theorem. On this problem, if I wanted to evaluate P of 4. Before today, you would have to go in and you'd replace every x with a what? A 4. And we can still do that. We could do 2 times 4 cubed and minus 4 squared, and we could work it all out. Or if we don't want to have to cube and square things, maybe it'll just naturally happen here. Am I dividing, like I'm trying to find P of A, right? So let's go ahead and divide this thing, P of X, using synthetic division with an A on the outside. What is the A value right here? P of A, and X minus A, P of 4, it's a 4. If we're doing synthetic division and we're using the remainder theorem, what goes in this top row? 2, negative 1, 1, and 3. Okay, looking at this. This one's value depends on the person, but let's just try and see what shakes out. 2 drop straight down. Now what? 4 times 2 is 8. These add to be a 7. Now what? 4 times 7 this time is 28. That adds to a 29, and that's kind of gross, but we'll deal with it. 4 times 29, I think, is 116. And these add up to 119. Now, this is my remainder, right? What we have just found is rather than doing 2 times 4 cubed, blah, 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 we just found, therefore, and I'm going to use the 3 dots for therefore, P of 4 was equal to, what was the remainder? Instead of doing the power stuff, we can evaluate functions this way, and it works nicely. Easier or harder than doing it? Don't write this down, but is this better or worse than doing this? I think it's better personally, but somebody might prefer this. If you prefer this, are you going to, like, is that okay? Yeah, we'll get the same answer. This is a nice time-saving trick. All right, so for tonight, because I forgot to give you guys, or put it on the classroom, out of curiosity, there's no penalty. How many of you guys had the assignment done today? Okay, fair. I want you to add the following problems. Still page 148, you're going to add 20 through 30 and 34. No, you're right. I can do odds and evens. You're right. I agree. You'll see. It's much quicker than you think it is. Synthetic division take a long time? No, it's quick. Add 20 through 30 and 34. Cool. Yes. No. Okay, if you need it, the other assignment, if you didn't do anything over the break, it's up on 12/2 from last Tuesday. Cool. You guys have a wonderful day. Wrestling tonight starts at 5 o'clock. I think we have a spotlight, and Miss Bagley has some glow sticks and stuff. Cool. Later, Raiders.